Let's talk about f orbitals. This will be the last type of electron configuration I review. So let's do the configuration for tungsten. Chemical symbol W, atomic number 74. This will also be a review of s, p, and d orbitals. So let's do its electron configuration. So let's start off with 1s2. Here it is, the 1 and the s2, and here we go. Now, moving right along here, then we move on to 2s2. Here it is, the 2, the s2, and there it is. Now, moving right along here, let's go on to the p block. So here's the 2p6. How did we get that? Here's a 2, and we're in the p block here. And here's a 6, and I've written it there already. And I did this configuration ahead of time just to make it easier and faster. Okay, now moving right along here. Now we're going to go to 3s2. Here's a 3. Here's the s2. There it is. Now, moving right along here. Here you go to 3p6. Here's a 3. Here's a p block again. And here's a 6. All right. So moving right along here. Now I erase things because we're going to circle them again and whatnot. So we already did the 3p6. Now moving right along here. Here's the 4s2. Here's a 4. Here's the s2. There you go. Now, moving right along. Now you hit the D block, and we've already talked about this block, and you can go to a prior video to review this again. But this block right here is going to be 3D10, and this is a D block again. So here's a 3D10. Now, moving right along here. Now we're going to hit the P block again. So it's the P block 4. And here's a P block and the 6. And here it is. Now, once we're done with that, already did the 4p6. Now we're going to 5s2. Here it is, 5. Here's the s2. Now, we're in the D block again, and we've already discussed this block, so I'm not going to go over it. So this is 4D10. Here's a D block. Here's a 10. Now moving right along here. This is a long one. Okay, so now we're at 5p6. Here's a 5. Here's a P block. And here's a 6. All right. Now moving right along. Okay, so we have the 5p6. Now we have the 6s2. Here's a 6. Here's the s2. We're almost there, you guys. Patience is a virtue. Okay, now we're going to hit the F block. So we already finished off with 6s2. So what happens here? Then you will see element numbers 57 to 70. And I've already marked them here. Here's your 57 to 70 right here. All right. Now, that being said, Those elements comprise the 4F block. Now, element 71 right here, they go in this little block right here, this pink block right here, all of this. Now, element 71 is going to start off the first column of the D block, all right? So it's not part of this 4F, it's part of the D block. Just trying to explain it here. So that being said, now there's also a 5F block, which is comprised of element numbers 89 to 102, which is the bottom ones down there. So we won't discuss those in this configuration. I'm just letting you know what those are. And element 103, of course, would start off here in the D block. So it's not part of that 5F. It's part of this D block here. So I've already explained that. So it gets a little bit complicated here, but just follow me. So let me just take all of this off since we already discussed that right now. So that being said, why is it 4F? Well, tungsten will fill up its fourth energy level with a maximum number of 32 electrons. So it took all the way to the 6th period to complete the fourth energy level. Now, if you think about the D block, it was one period behind. That's why it would always start off like the fourth period would be the 3D block, right? And you can go back to the prior video on d orbitals to study that a little bit more. Now, going back, so it took all the way to 6th period to complete the fourth energy level. And tungsten is in the 6th period. Hence why you subtract off 2 from the 6th period, making 4 the coefficient to start off the F block. And if you remember in a prior video on energy levels, the formula is 2n squared, where in this case, the energy level is 4. So substitute the n with 4. So 2 times 4 squared equals 2 times 16, which equals the 32 electrons. This is getting really complicated, but this is the best way to explain that. And I will show you how we come up with the 32 electrons. So after all of that I've just said, we stopped off on the 6s2 configuration. Now, what we're hitting here, as I was talking about 4F. So 4F was those 57 to 70 elements. Now, if you count all of these elements, there's 14 elements. So tungsten is element 74, and we're going from 57 to 70, those elements. So you're going to start off your configuration with the 4F as you see here. And there's 14 elements if you count them. So you would count, let me just tap, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's your 14 elements, hence the 14 superscript there. So that's how you get the 4F14. Okay. Now, the only last thing you have is, guess what? You have to do the D block. And we already discussed this element 71, it goes right here again, right? So that being said, your 6th period is going to be the 5D because we're one period behind, remember? And go back to a prior video on d orbitals and you'll know how to do that. So here's a 5D, and you're going to count 1, 2, 3, and 4. There's tungsten. There's a 5D4. Now, think about it. Okay, we said the fourth energy level has 32 electrons. So let's just look at that energy level. We have okay, so let me erase this. That way I can show you. Since we already completed the electron configuration for tungsten, which was really long. I mean, you can use the shorter electron configurations that I talked about in an earlier video where you use, that shorter electron configuration, but I wanted to show you how to do the whole electron configuration, all right? And everything else falls into place. And you can go watch the video on short electron configurations and you can figure that part out. But that being said, the fourth energy level is right here. So you have the 4s2 with the superscript of 2, so there's 2 electrons there. 4p6, so 2 plus 6, that's 8. Then 4d10, so 8 plus 10 is 18. And then 4f14, so 18 and 14, guess what? Is that magical number of 32. So how cool is that? So if you can become an expert on this, you've become an expert on electron configurations. And if you want to just do on your own time more complex electron configurations, you can use this as a basis. So this concludes my lesson on the f orbital electron configuration for tungsten.